product rule. It's hard to memorize all the rules, and when you get on the SAT, you're going to like second guess yourself about all the rules. So repeated multiplication is your fallback. If you forget the rule, what you should do for yourself is think about, if I multiplied out x to the fifth, what would it look like? If I multiplied out x to the third, what would it look like? How many x's are being multiplied together? 8 of them. So what did I just do? I added together the exponents 5 plus 3. So it's really x to the 8th, and what you're allowed to do is add together the exponents. So there's going to be 7 different properties. It's hard to memorize them. If you ever doubt yourself, write it out for yourself. Make sure that it is addition, because one of the properties is you multiply the exponents together. So if you're unsure, ooh, is this x to the 8th or x to the 15th, you can just double check using repeated multiplication. Same thing for the quotient rule. All right, how do I simplify this? If I have x to the 4th on top and I have x cubed on the bottom, think about what's going to cancel. 3 of those x's are being divided by themselves, and you'll have x to the first left in the numerator. So it's really x or x to the first. What did I just do? I took 4 and subtracted 3, right? So the property is you can take the power of the numerator and subtract the denominator. But basically you're just canceling, right? So you shouldn't have to memorize these. I tend to know them because I've used them a lot. Don't feel like you have to memorize. Repeated multiplication works just as good. So the power rule. So now you've got x squared to the third power. So something to the third power looks like this. You multiply it by itself 3 times. So what is my actual power of x? X squared times x squared times x squared. X is x to the 6th. So what did I just do? The shortcut is when you distribute an exponent, you can multiply the exponents together. See how now that we have 3 different rules, you might get them confused or second guess yourself. So always double check using repeated multiplication to make sure you have the rule correct in your head. Because these, if you get some simplifying problems on the SAT, those should be easier type questions that you should get right. And then the distributive power is really just the distributive property. If you have an exponent outside a parentheses and there's multiplication, so this does not apply to like binomials, right? I'm not allowed to distribute to a binomial, but this is now a multiplication problem. So I take the nth power and I distribute it to both of the terms inside. And this is the one that gets missed the most. When you have 3x cubed, both of those terms get the distributed x squared here. So you have 3 squared, and then you have x cubed that's also being squared. So your final answer would be 9x to the 6th, and a lot of people miss that. They'll put 3x to the 6th. So these are separate, you know, they're not factors. They're separate parts of this problem, right? 3 is being multiplied by x cubed, so they both get distributed to. And then same thing, even if you have a fraction, you have to distribute it to the numerator and to the denominator. And we did one like that on the warm-up problem, right? 5 halves squared was 25 over 4, so you could distribute it to both. So this one, you're going to multiply to the numerator and the denominator. So you'll have x to the 6th in the numerator and y to the 12th in the denominator. So you have to know that multiplication rule and the distributive rule. Do these seem like you've learned them once upon a time? They're just, maybe you forgot the rules or whatever? Okay. So these should be a refresher. And then I think the fractional exponent rule might be new. I don't know if you ever did the negative exponent rule before. So The negative exponent rule is you take the reciprocal and move it to the other location. So I'm going to move it to the denominator and make it a to the positive nth power. So up until now, I just told you that that was the rule, but why? And I showed it to you in the table of powers too, right? It made sense in our table of powers that the fractions, right? If I'm in the power of 2, then if I keep multiplying by 2, I keep going across the row. So the fractions made sense in this row, it fit, but why is it actually the case? This isn't really a proof, but it kind of gives you an aha moment. So it says, let's simplify the following using repeated multiplication and canceling. Okay, so I would have a cubed on top and a to the 4th on the bottom, right? That's repeated multiplication. I can cancel out 3 of those a's, and I could write my final answer if I wanted to as 1 over a, right? Because I have 1a left in the denominator. Anything divided by itself is 1. What if I use my quotient rule? My quotient rule was taking the exponent and subtracting them. What is 3 minus 4? 3 minus 4 is negative 1. So it's showing you that you started with the same fraction. You tried repeated multiplication and the quotient rule. So those are equivalent statements. So it's not a proof, but it at least is showing you how those are equal to each other. So when you have a negative exponent, all of these you're going to move to the denominator and make them a positive exponent. So this will be 1 over 45 and 1 over x squared. I feel like I should have added an example of something that starts in the denominator. So if you had 3 over x to the negative 5th, right? So why don't you add this one? How can I take my negative 5th power and make it a positive exponent? I just have 3x to the 5th in the numerator, right? So I'm allowed to bring this up top. Now I just have 3x to the 5th. So I think of negative exponents as they're negative, they're not happy. You move them to the other location and it becomes a positive, happy exponent. So we don't want to have any negative exponents. We're going to make them all happy exponents. And then the last rule, we've already talked about that anything to the 0 power is 1, but why? So let's do the same little proof that we did up top. If we do canceling, right, a cubed over a cubed, what happens? All 3 of my terms get to cancel, and anything divided by itself is 1, right? So if I use repeated multiplication, I get 1. What if I use the quotient rule? The quotient rule says I can take the exponent and subtract the other exponent. Well, isn't 3 minus 3 0? So isn't this a to the 0 power if I use the quotient rule? So those two things have to be equal to each other. So down at the bottom, 12 to the 0 power must be 1. And this parenthesis to the 0 power, you don't even have to distribute it. Anything raised to the 0 power is just 1. And I should have pointed out, if you have a to the 6th, b to the 7th, you can't simplify that. Those are not the same base. So these rules only apply if they're both bases of a or bases of b, right? So you can't simplify unlike bases. So just to add that to the rule. So I would like you to take, you got your rules. There's, I don't know, quite a few practice problems over here where you've got to distribute, simplify all of these as much as you can, and there's a little bit more practice of evaluating down at the bottom. And I'll give you like maybe 10 minutes or so, and I'll walk around and, I can check your answers, see which ones you need help on, and then we're going to talk about the fractional exponent rule. And make sure on number 10 You remembered to distribute the square to the 8, so you should have 64c to the 10th. So just make a mental note. If you only wrote 8, you forgot to distribute the square to every single thing inside. Number 9 should just be the number 1. Did we do okay on the rest? Make sure that this was x to the 6th because it's 2 times 3 for number 8. And then 11 through 13 are definitely a little bit more challenging. And my strategy is always to move my, oops, why can't I? Always to move my things that are negative first. So before I started this problem, I took this 3 to the negative 2nd and made it 9 in the denominator. I combined and made x to the 5th in the numerator, and I moved the 12 down to the denominator so I could clearly see that I would have 7 left in the denominator. If you just wrote 9x to the 7th, it would be incorrect. You need to show the 1 that it is in the denominator. So just look for yourself if you wrote the 1 there, because you need a 1. And then, did we do okay on the rest? Fairly well? All right.